this a little bit about me. I'm the technical director of professional services at Curity. So I'm working with our customers every day to try to uh, teach them about the identity and API problem, but of course create solutions. That's what we do in our team, and we're a group of identity specialists. I'm a former Java developer, still do a little bit of that. I'm an avid Pokemon Go player, so if anyone here wants to be friends, hit me up. If you know Pokemon Go, level 46 is not something to brag about. But more importantly, just a few years ago, there was almost like a race to the cloud. Everybody was going to leave their on-premise, go up to the cloud to get access to these easy-to-maintain platforms where you basically leave over everything about your systems to other parties. That could cut costs and make things simpler. And it's, of course, very tempting to do so. But recently, with new legislations and regulations in play, and that race to the cloud has been more, there's more to think of. It's not just an obvious just to deploy here and you have everything, but you always have to think of where to put your data and how to manage it. And legislation might even tell you that you're not even allowed to put your data in the cloud. So it's not an obvious choice, and it requires some thorough planning. So what I'm trying to say that you need to keep control of your data in your systems. You need to keep the control of where everything is stored and how people and machines are accessing your data. You need to design for resilience of your platform. Just a short example, this is not something that's new. This is something that you already are doing in your platforms and have been doing even on-premise. But you need to prepare for if your database is down, of course. And in many places, you already have a passive copy there so that you can just replace it and nothing ever happened. Similar things for your API. You have your pipelines in place so that when your monitoring system discovers that an API is down, we can quickly spin up a new node, and it's exactly like before. We have something new in place, but it's now answering to your requests. Same thing can be said about your API gateway, of course, but you may also already have a failover cluster in place so that you can easily reroute your traffic to another cluster and start serving requests. So this is not news. Deployments have been looking like this for quite a while, and in the cloud you can do pretty much the exact same thing. So we need to continue doing this, of course. Sorry. But a common thing for all of these types of platforms is that we need to also have control over whoever accesses our platform, be it users or applications or machines that is coming in. They need some kind of proof that they're allowed to come in here. They need a token, pretty much. So we have a strong belief in the token-based architecture. Every request should be authenticated by a token. And this token needs to come from somewhere. So likely an OAuth server, but it really could be any other protocol that it's helping us create this proof. But if we're not in control of this identity system, the OAuth server, what happens if it goes down or is otherwise unavailable? So this is what I mean with the identity is the kill switch, right? Whoever controls your identity system have so much control over your system that it can effectively turn it off. If you can't log in, you can't have access to the services. This is directly connected to your revenue stream. If your users can't log in, they can't buy stuff from you, and they can't see their own data or whatever your service is. There's no access anymore. So having a full control over the switch is key for your business. So we need to take control over the switch. So be it that you put it in all over into your platform and hosting it yourself, or if it's just having the control over your identity system is very important. It doesn't mean that you need to host it in your closet, but you still need to have control over where it is, the uptime of it, how they store data. All of that is not something that you need to have control over, both for the reason of that you don't want it to be able to turn off, but also to be able to comply to regulations. So we need the same type of protections in place that we had for the simpler platform. Now that we have this identity system, we need the failover cluster, we need to be able to spin up new nodes, everything like that. And depending on your use case, we can also hedge our bets, put them in multiple different regions, different clouds providers, just to be able to ensure that we cannot lose the control over the identity switch. But we must also talk a little bit about authentication methods. So yeah, we do have an identity system and we're authenticating users, but different authentication methods have different properties. So they're not all the same. They have different types of security, but they have different dependencies, and they can give you different type of data. Let's start with a national ID type of authenticator. So I'm a Swedish man. I use our Swedish bank ID every day. Us Swedes are very used to using this in pretty much any service that we use. We log into the retail store just as well as we go to the bank and use the same type of ID method. It's a very good method, but not every country has something like it. They differ in UX, they differ in inconvenience, and then differ in adoption. But one thing that they have in common is that they are a high assurance authentication method, and they provide some data around the user, and not only just the identifier most of the time. So, but when we're relying on this type of method, what we've done is really just to move the switch. Right? The switch is now the national ID. If the Swedish bank ID is down, pretty much anyone can log into anything. We had a situation half a year ago where it was down for 3 hours. Made every headline. So we need a break glass situation where when this type of provider is down, we need to offer alternatives. So we need to provide other means methods to be able to log into our system when the national ID fails. So, of course, username and password works. Everybody knows how it works. It's simple, not the securest method, and we kind of all know that we want to move away from them. But at least it has no external dependency, so we can use it local on our servers. Time-based OTP would be a step up, meaning authentication apps where you get an OTP where you can use into your authentication method. It has no really external dependency, but it relies on a shared secret. So we need to have set up a shared secret between the user and the server to be able to actually use it. Passkeys, I would, in my personal opinion, is also a step up because we don't have the shared secret, first of all. It's asymmetric crypto, so we only need a public key in the server. It's quite convenient for users since the keys are synced in the ecosystem if you want them to, so you can use multiple different devices. So you don't need to always log in on the same device. And it also has no external dependencies for the server. Of course, for the user, we have problems if we're relying on the syncing and we haven't synced before. We need to have connection to our ecosystem. But what all these methods have in common is that we need to have some kind of centralized user data to be able to use these as a break glass method or as an alternative altogether. We need to have registered users. We need to have provisioned a shared secret or the the key pair for passkeys, which might be easy if you're having only one one server where you don't need to replicate data. But if you're coming into a multi-region setup again, can we really sync these data across the regions? Should the user be able to log in everywhere? It creates problems, and legislations doesn't really make it simpler for us. But what I'm trying to come to is, of course, the verifiable credentials. So verifiable credentials is a authentication method that puts the user in control. The user holds the data around my identity, and I can choose to share it with the parties that I want to share it with. And there's no online actor in these, and we can consider it quite future-proof, since we were still very early on the journey of verifiable credentials, but it looks like it's getting adopted. So I think this is where we're heading. It's a standardized method, standardized by the OpenID Foundation and others, I would say, but the issuance and presentation protocol is on the OpenID Foundation. It enables a decentralized identity where I can hold my credential by myself, and I don't need to put it in a cloud somewhere. I can present it whenever I need it. Verifiable credentials are often described as putting the enabling the user to be self-sovereign, so that I can keep control of my data. I don't need to share with everybody else. But it also enables the server to do secure authentication without knowing the user before. We don't need to have a lot of knowledge about the user before it comes there the first time. So it works really well as an alternative to these national IDs. And of course, we're hoping for national IDs to become verifiable credentials, so we don't need the external server. So if I have a verifiable credential and we accept it in the server, I can go to the identity system and present my credential. And I have the option to select what data I share in that moment. So I have a credential that contains a lot of information, but with this particular one, I only want to share my name and my employer. So this is up to the user, and the server gets to decide if that's enough data or not, and decide if they need to let them in. But typically, the only thing you need to trust is the issuer of the data. So if this data that I'm sending right now is issued by a minor company somewhere in Stockholm, I might not trust it. But if it's issued by a bank or a government, then yeah, the trust is a bit higher. So the server can hold a list of issuers that it trusts. So decide I only trust governmental data, or I trust any issuer. I'm just interested in an identifier. So we don't have any external dependency in runtime, at least, and we don't need to store as much PII in the system. So verifiable credentials is very new, as I said, but we're already seeing some adoption. Use cases are emerging, and it's starting being used here and there. But I think it will very much get some speed from the EU legislation coming next year. So the wallets are being legislated by end of 26, and I think end of 27, member states actually have to be able to put something in there. So we're not really there yet, but I think it will take on fairly soon. So with authentication methods that are resilient, we of course need to be able to get that over to API access. So when an application has been given a token, or the user logs in using any of these methods, we have some user data in the system that we need to be able to share with our own system, but we can't really convey them back to the application, both for regulatory purposes but also privacy purposes. The application outside our platform does not really need the user data from us, but it also can't see it in some situations. So just want to talk about some patterns that we can enable that with. If you've seen Curity before, we might have mentioned phantom token a couple of times, but I think it's good to bring that up in here and maybe repeat it a little bit. So the phantom token pattern is using standard OAuth specifications, but connecting several ones. But it relies on the fact that the client is requesting access and then being issued a token. This token points to information about the user. It represents the user data in claims that we have. But the format of the token does not convey that information. It's an opaque token that is only a random string, so it doesn't really mean anything to anyone who reads it. It only means something for the OAuth server themselves. So when the application calls an API, we need an API gateway to intercept it and dereference this token and switch it into a JOT, which is a readable format, so we can have the claims in clear text and being able to validate those claims in the API and being able to authorize the request based on the data that we got there. So the phantom token pattern hides identity data from the external parties, but it gives the API the possibility to have all the information there that it needs, and can validate the token independently and authorize correctly based on that information. So one more pattern, the heart token pattern. So heart token gets its name from American healthcare specification that uses OpenID and OAuth specifications connected all together. But they also have a token format in there that is a token that is, it's an opaque token, but not really. It's actually a JOT, but it does not contain any information that is readable for a user. So the information that's in this JOT is merely about who issued it. So, but no information about the user that logged in or the machine that got this token. But with that, it enables some routing that can take place. So if you're in a situation where you have multiple clouds or multiple clusters with different issuers, that we're in silos, you should call them, but we have API gateways that only connected to their own OAuth server, so they can only introspect token from their system, and we have a similar one only connecting to their system. So this application has been given an EU token, meaning that the user logged in the EU region, but the application somehow decided, I call the US region now. I don't know, perhaps for the user clicked the link that it shouldn't have or something like that. So in a normal situation, this token would just be rejected because it's not issued by me, so you can't come in here. But since this is a hard token, we have the metadata, the API gateway can pass it on to the correct one. And the API gateway can then decide what to do with it. Should I reject it because you're coming from the wrong region, or do we actually have a copy of the API here that we can serve from the correct region? The hard token simply enables this routing possibilities. And it's very useful in these types of silos where we can connect different systems that are completely separate, but perhaps they are owned by the same organization, so they shouldn't be entirely separate. So in summary, take control of your kill switch. It's really important. If you leave that switch over to a third party, some bad things might happen. And even if they don't, it's a big risk, and it's connected to your revenue. So thank you for me. Hit me up after if you want to play Pokemon Go.